Okay, we learned two types of area. Area with respect to x, area with respect to y. Area with respect to x, both of your equations have to be functions with respect to x, which means they're in y equals form, and they have to pass the vertical line test, or some of your teachers might have called it the pencil test. Okay, same thing. Okay, so let's say that f of x is here, g of x is here. Okay, then when you are integrating, your boundaries would be across a domain. Domain goes here to here. So we'll say that this one's A and this one's B. Then when you set up your integral, remember that it is top minus bottom. Okay? And then that would be for this little pocket of area right here.
What happens if they don't have vertical arches?
Then you couldn't do the integral with respect to x. Okay? So we're going to do a real quick little example. We're going to do it all the way through because we didn't do a lot of them by hand all the way through on Monday. So look at number 1. Okay, 1 over 3x plus 1 looks like this. Okay, that's going to be my f of x. Notice it passes the vertical line test, that it's in y equals format. Okay, and then it says it's going to be below by g of x equals negative 4, which is a horizontal line. So 1, 2, 3, 4, we'll say is right there. And then draw your line across. Now notice that those do not ever intersect. Okay, this is going to keep going towards 0, but it's not ever going to cross it to hit negative 4. But they gave you a domain. Where are we integrating from? 1 to 4. So we'll say 1 is here, 4 is here. Then that would be your space that you're trying to find. Okay? So we'll say this is x equals 1, this is x equals 4. Okay? So set up your area. It's going to be an integral from where to where? 1 to 4. And then which of your functions is on the top for you to subtract first? F of x, which is 1 over 3x plus 1, minus, and then my bottom function is negative 4. Okay, now, on the AP test, they could ask you to do this one by hand. Would you do it together or separate? Separate, because why? This part needs u sub, but the other part doesn't. So that's how you know whether you can do them in one integral or if you have to separate. So I'm going to go 1 to 4 first, 1 over 3x plus 1 dx, and then plus integral of 4 dx from 1 to 4. Now notice I'm only changing the 4 to a plus because it's a double negative. They cross out. Okay, let's do this one first. What is my u going to be? Okay, 3x plus 1, good. So u is 3x plus 1, which means that du is going to be 3 dx, which means that dx is du over 3. So I'm going to rewrite this first part of my integral here. Okay, I'm going to do it, I guess, here. Okay, it's going to be 1 over u, because remember, my 3x plus 1 is my u now. And then for my dx, I'm going to plug in du over 3, but I'm going to make it a third in the front. Okay? From there, I need to rewrite my endpoints. My upper was a 4. What is 3 times 4? 12 plus 1 is 13. And then on bottom, I'm plugging in a 1. 3 times 1 is 3, plus 1 is 4. Antiderivative of 1 over u is... Okay, so it should be a third ln u in the brackets, plugging in 13 and 4. Now, when you're plugging into ln, most of them you're not going to know. So I'm just going to call this ln of 13 and ln of 4. You're not expected to know those. You would need a calculator to do that. Okay? So let's set this up over here. So the first part of my integral is going to be ln of 13 minus ln of 4, and then I have a 1/3 in the front plus. Now I still need to work out my second antiderivative, which is just a 4. So what's the antiderivative of 4? Okay, 4x. And then 4x, I'd be plugging in 4 and 1 and then subtracting. Plug in 4. 4 times 4 is 16. 4 times 1 is 4. Subtract, you get 12. So this would be your area. You would go from here with both integrals set up to here, which would be your final answer. That would be your area. Okay. Got it? So U sub on one part, normal on the other. Now, on the actual AP test, you should try to organize that better. I just did it poorly. But you want to make sure, like, should these two things have an equals between them? No, so I'm going to go back and cross that out. Okay, because this is only my one part of my integral. This is the other part of my integral, and then I'm adding them together down here. So these are equal to each other. Okay, but those first lines where I put the equals, those really aren't. So just go back and cross out your equals if you put it. Okay, the other way to do area is with respect to y. So your functions would be in x equals form. And they have to pass the horizontal line test. The other thing that you should remember if you were here on Monday is that your integration boundaries are across the range, which means that instead of them being x values, they're actually going to be y values. Okay, and then your integral will be set up right minus left for the order. So let's sketch a real quick picture of that, and then we'll do the next example. So we'll say f of y is here. And we'll say that g of y is, I don't know, here. Then the area between them would be the integral between the y values of the intersections, and then you do right side minus left side. Okay? And we're going to set up a bunch of these today. You'll notice if you flip that I put graphs on there, like they will on the AP test. So, take a look at number 2. Second warm-up, this is your dy warm-up. What shape is y minus 2 squared? What shape is y squared? Okay, x squared opens up. Which way does y squared open? To the right. Okay, now, normally a minus 2 would shift my graph to the right, which is positive. Which way is it going to shift it if it's an x equals equation? So think about, instead of left and right, it's going to be up or down. Which one is positive? Up, the y-axis. So I'm going to count up 2. Put your little dot, and then make your graph open to the side. Okay? Because it's x equals y minus 2 squared. So since it's an x equals, it kind of like just makes everything backwards, to where this is actually changing your y in the positive direction. Because remember, the one in the parentheses is always the opposite. Okay? Then from there, y plus 10, x equals y plus 10 is going to be linear. And instead of 10 being the y-intercept, now it's the x-intercept. So I'm going to say 10 is right here, and then I'm just going to draw my line in. Now, what if you had drawn your line going that way? Ultimately, does it matter? No. Okay, you might draw the line going kind of slanted the wrong direction, but either way, which side is the line on, the left or the right? It's on the right side. So even if you had drawn it going this way, that would not have changed. The important thing is who's on which side. So, shade your area. There's my region. And then I'm going to go ahead and set up the integral part. It's going to be right minus left, which is going to be the line minus the curve. Line minus the curve. So the line was y plus 10, minus the curve was y minus 2 squared dy. Okay, other thing we need to find are intersection points, because those are the boundaries of the integral. So if you were here yesterday, we did one like this. If you weren't, there are two on your homework that look like this when you're solving. Okay, so if you were here yesterday, how do you solve y minus 2 squared equal to y plus 10? What would you have to do to this side? You would have to times it out or expand it or FOIL it or whatever you call it. Okay, so you need to expand this side so that you can factor it. So you guys do the square, double square. So it'd be y squared, doubled is negative 4y, and then squared would be a plus 4. Now, you cannot factor with your terms on opposite sides, so we're going to take our y across. If I minus one more from negative 4, now it's a negative 5y. And then if I have a 4 here and I minus my 10 across, now that's a minus 6. What numbers will multiply to 6 and subtract to 5? 6 and 1, which order? Which one should be negative? The 6. Because remember, if I want to get a negative 5 in the middle, then my 6 had to be bigger, right? And it had to be negative. So take a look at your graph, label your y values. They cross at negative 1, which is right here. And then they cross at positive 6, which is here. And those will be my boundaries. Boom, boom. Okay? Now, integrate together or integrate separately? Together? Separate. Which one? Separate. Because why? This one is normal, but what does this one need? Okay, u sub, which is kind of like the chain rule for antiderivatives. So let's do the first part here. I'm going to have y plus 10. What's the antiderivative of that? 1/2 y squared plus 10y. Plug in 6 and plug in negative 1. Okay, well if I plug in 6, I get 6 squared cut in half is 18, because it'd be 36 cut in half. And then 10 times 6 is plus 60. So that top part came out to be 78 minus. Now let's do the bottom part. Plugging in negative 1. Negative 1 squared is going to be positive 1 times a half. And then plug in your negative 1 times 10, that's a minus 10. Now, you can put those together if you want to. I'm not going to because I don't have to. It's a free response. I'm just going to leave it alone. So the first part of my integral is this right here. Now, what is 78 minus negative 10? Positive, so really that's 88 minus a half. That's the first integral for this part. Now, for the second integral, what method did we say we're going to need? U sub, what will your u be? Y minus 2, which means what's du? What's the derivative of y minus 2? 1 dy, which means that dy is just du over 1, remember? Okay, dy is just du over 1. And that tells me that I'm not going to have any weird numbers that I have to put out in the front or anything like that. Okay, let's rewrite our integral. So it was originally the integral of negative u squared, right? Because this is my u, and it was squared, and then a du. What else do I have to remember to change? Yeah, endpoints. Very good. If this is a 6, what's 6 minus 2? That's a 4. And then if this was a negative 1, what's negative 1 minus 2? Negative 3. Antiderivative of u squared is what? So add 1 first, so now it's u to the third. And then divide by 3, it's a minus 1/3 in the front. Okay? Then I'm going to plug in capital F of 4, then capital F of negative 3. Now remember that since I changed my endpoints, I'm not going to go back to y minus 2 again. I already plugged into that part, so I'm going to plug in for my u. What is 4 to the third power? 64. So negative a third of 64. And then negative 3 to the third power. Actually, question, if there's a negative third in front, how many negative 3's do I actually really need? Only 2. Because one of them, from the cubed, can cross out with one of them from the negative 1/3. Okay? So it's really just going to come out to be 27. Or wait, hold on. 3 times 3 is 9 times 3 is 27. Then divide by 3, it should be back at 9. Sorry. Okay? And then what do I do with those two guys? Subtract, yes? So you'd have 4 sets of negatives because you have 3 negatives in here because it's cubed, and then you have the extra negative here. So if there's 4 negatives all together, 2 of them will cancel out, 2 of them will cancel out, 9 will turn out positive. So I would just count how many negatives. I have 3 in here, and then 1 more right there, that turns it back to a positive. And then from there, it'd be negative 64 thirds. And then would it be plus or minus 9 when I do top minus bottom? Minus 9. And then what do I do with those 2 little highlighted sections? This is area 1, this is area 2, then I add them. So it'd be 88 minus a half plus negative 64 thirds minus 9. Now, none of you have asked it, but you might be thinking, well, wait, that was a negative. You're right, but where did we bring the negative? Into the integral. So you wouldn't also put a negative in the front if you went ahead and pushed the negative into the integral. Okay? Yes, ma'am.
So instead of, if you didn't write like the original minus 2 squared and you wrote the expanded way, then you would have to.
Yes. Okay, so what she said, that actually would have probably been pretty smart. She said, what if I just expanded this, then do I have to do U sub? No. Good job. That would get you around it. If you times this out, then you could have, I guess, avoided U sub altogether. Good job. Yes, good. Okay, turn the page. All right, so take a look at your little top section here. So it says, remember that the definitions of the areas on the front page only work if one of your functions is always bigger than the other for the entire interval. So if that is not the case, you're going to have to break it up. So this is what that means. If you're finding the area across a domain or range and the functions intersect, then the area needs to be written as a sum of 2 integrals. So this is what that means. Come over here, sketch a little picture. We'll say this is f of x, we'll say this is g of x. If I want to integrate from here to here, I would have to set up a sum of 2 integrals. So let's say I'd go from a to b. Let's say this one is a, this one is b, and then I'd have to integrate from b to c. So your area would look like this. A to b f of x minus g of x plus b to c of g of x minus f of x dx. Okay? And the reason why you have to do that is that your function that's on top changes. So like for this first one, who's on top? The curve of the line. So it'd be curve minus line. But then for the second pocket, you have to reverse it. So you would do line minus curve in that second one. Make sense?
No. Confused.
Oh yeah, because you were gone. So this is your first area,
Okay.
would be A to B, top minus bottom. Then plus, and then I'm going to do this area separately, B to C, top minus bottom. So you're basically taking the total area and you're breaking it up into 2 pieces. Okay? So look at the next one. You can see all my calculator or technology skills Okay, it says find the combined areas of the regions enclosed by the graphs. So the area that's enclosed, there are two pockets. I have a pocket here, and then I have a pocket here. Okay, so I have a little pocket, and then I have a big pocket. Now, just to save us on time, okay, these cross at whole numbers. Instead of having you solve for the intersections, just look at the graph. Okay, where is this? This is -2. Where is this? If it's exactly in the middle. -1, right? Because those are your negatives. Yeah. And then this one over here we said is, okay, we can just go ahead and label it 3. So when I set up my area, I'm going to do it down here at the bottom. It's going to be the integral from -2 to -1. Who's on top for this pocket right here? The curve. And the curve is F or G? F. So I would do F minus G plus, and now I'm going to go to my second pocket, which is over here. Okay, and I'll integrate from where to where? -1 to 3, and then who's on top? G of x minus f of x. Does that make sense?
Why did you include it? What are the red lines for?
I was just showing like this red area goes with this red integral. And then this purple area goes with the purple integral. That's right. Okay? Makes sense? So you're just taking the two areas, add them together, boom, that's your answer. Okay, go down to number 4, please. Now, what do you notice about your functions on number 4? Do they pass the vertical line test? No. What do they pass instead? The horizontal line test. That means that while the one above it was a dx, this one is going to be a dy. Now, instead of looking for the x's of the intersections, what am I going to be looking for? The y's of the intersection. So put dots here and here. Where do they cross at this height, the top one? Y equals what? 1. And then where do they cross down here? What's this one? -2. Okay, so we have our intersections. Now this one doesn't look like it actually crosses, but read the question carefully. What does it say? I want to find the combined areas enclosed by the graphs on the interval from -2 to 2. So when I shade, I'm gonna start at -2, but I'm not gonna stop at 1. When am I gonna stop? What does it say? 2. So I'm not going to stop till I get here. And do you see where that second pocket comes from? They're making you shade past when the graphs intersect. So because they gave you a range here, I have to keep shading beyond where they cross, which is where I would have normally stopped. Okay, so we're going to call this one pocket number 1. We're going to call this one pocket number 2. For my first pocket, is it going to be line or curve first? And I'm talking about the bottom pocket here. Okay, the curve first. Why? Because it's on the right side, right? It's right minus left. And then when I get to this top pocket, who's going to come first? The line. This is the right side. Okay? Now, there's one other thing that's tricky about this one. Don't start writing your integral yet. You will notice that your equations are not in the right format. What format are they in here? Y equals, what are they supposed to be in? X equals, but it's an easy fix. If this is x minus 1, how can I solve that? Take the minus 1, move it over as so it's x equals y plus 1. Your equations have to be in a format that is compatible with integrating dy. So you have to fix your equations to be in x equals form. Now look at the other one. Okay, I had y squared equals 3 minus x. That's not going to work. I'm going to move the 3 across. Now it's a what? y squared minus 3, and then what do I have to do after that because of the negative? Divide by -1 or just change all the signs. So these are the equations that I'm going to use in my integral. They have to be in x equals form, and they'll do that on the AP test sometimes. They'll give them to you in the wrong form. Okay, so let's do this pocket down here. I'm going to do it in red. What are my boundaries? What are my numbers? Where to where? For the red one, -2 to -1. Or I'm sorry, I said that wrong. -2 to +1. And then who did we say is on the right? The curve, which is -y squared plus 3 minus y plus 1 plus. Second antiderivative is going to be the top part, okay, which is right here. What are my endpoints going to be? From where to where? 1 to 2, and who's on the right up there? The straight line minus the curve. Okay? And then remember that when you're putting these into the calculator, if you use your alpha trace, y1 and y2, you don't have to worry about all the parentheses. Okay, you should write them, but in the calculator, you'd be using those shortcuts. Okay? Turn the page. Yeah, sure. Okay, look at the next one. Okay, go ahead and shade where it's telling you to shade in part A. So read part A right below the graph. Okay, part A says that you want to find the area that is enclosed by the graphs. Enclosed by the graphs. How many sections are enclosed by the graphs? Only one. So is that going to be a swivel where they change? No, it's just going to be one integral. Where will I integrate from? Oh, actually, we're going to have to find those points. This is where your calculator comes in. Type those in, find where those cross. So we're doing y equals here 1/2 e to the x plus 1 and 3x squared. And notice that the reason we're having to find it on this one is because they don't just cross at nice, easy whole numbers that we can just look at the graph and see. So, second trace, I'm choosing option 5, which is intersect. Mine is zoomed kind of weird, but oh well. Okay, I'll only be able to find the one on the right. 0.8505. Can somebody tell me the other one? What is it? 0.6484. Okay, so when I set up my integral, I'm going to go between those two numbers. So it'll be integral of -0.6484 to 0.8505. And then when I subtract, you can tell on your calculator, okay, but which function is on top for that pocket? Which function is on top for that little pocket? Is it the e to the x or the quadratic? It's the e to the x, because look, this is e to the x right here. Okay? So I need to do f of x minus g of x dx. Okay? Now go ahead and type that in. I want you to use your shortcuts. Okay, you should already have your y1 and your y2 typed in. So you would just do second quit, math 9, negative 0.6484 to 0.8505. And then remember that when you get here into the middle, you're doing alpha trace. Do I pick y1 or y2 first? Which one came first when I typed them in? I typed f in first, that's my y1. So I'll do y1 minus alpha trace y2. and then dx. 1.5200. So see if you have any trouble plugging that in. We good on that? We know how to do that? Okay. Part B, we're only going to set up. We're not going to type it in. So read what it says, and then I want you to reshade your graph. I'm going to just redraw it. This is part A. This is part B. Okay, where is it telling you to shade on the next one? From where to where? 0 to 2. That's not the same region. So I'm not going to start shading until 0, which is here. And remember, where do I have to stay? Between the graph. So I'm going to shade la 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 la. They cross. Oh, but I have to keep going till when? To 2. So I'm going to keep going until maybe 2 happens over there. And that's where you should see that your graphs swiveled on each other. That means instead of 1 integral, you're going to have to set up 2. Where will the boundaries be for my first part, which is right here? Where do I start my integral? 0. And then where do I stop? 0.8505. And for that chunk, f of x was on top minus g of x plus. Then for the second little chunk, I'm going to pick up at that same number, but I'm going to shade all the way until 2, because that's where they're telling me to stop. So I'll go from 0.8505 until 2, but it'll be g of x minus f of x. Make sense? Okay, so it could be that there are 2 pockets. It could be that they're giving you a domain that pushes you past where they cross. Okay? Because for this section, remember that g of x is the quadratic, which is this one. This is x squared. And so for that red part, the quadratic is up here on the top, and the e to the x is on the bottom. Okay? Alright, so I want you to do number 6. Okay, you can just set it up as fine, but go ahead and type them in. Okay, you're going to have to find where they cross in the calculator. They're not at whole numbers. Actually, this one is, but the other 2 aren't. And then I'm going to show you a shortcut. Okay, Marcel, wakey, wakey. You okay? Too tired? Oh. Okay, you might want to zoom in on this one just because it's so zoomed out. If you hit zoom in and then you push enter, it'll zoom it in for you. But you do have to push enter on it again. Okay, so has anybody found the middle intersection? What is it? Anybody got it? We know it's negative because it's on the left side of 0. 2071, okay? Then we just need that last one over there. It's got to be 1 point something because it's on the right side. Okay, 1.2071, good. Okay, so when I set up my integral, okay, it's going to be math 9, and then I'm going to label on here, this is my y1, this is my y2. Because I typed them in order. So I'll do area equals -1 to -0.2071. And who's on top for that section? G of x, because G of x is the curve. So it'll be G of x minus f of x plus And then for my second pocket, I'll go from negative 0.2071 to 1.2071, and that will be which one on top for that section? The line which is f of x. Now, in your head, you know that that's y1 and y2, but on your paper, you need to put the names that they were given, f and g. So we're doing math 9, blah, 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 blah. You can do it. Make sure it's y2 first, minus y1 on that first integral. That's what I got. Is that what you guys got? Oh, you got it? Yes? Okay. Alright, I'm going to show you a shortcut. Are you ready? You can only do this shortcut if you have a calculator. If you don't have the calculator, you have to break them up. Here's the calculator shortcut. Okay, what is the problem that made us have to break them up? The problem was that the subtraction order changed, right? This one had to be g minus f. This one had to be f minus g, right? What property, what math thing will make it not matter what order you put them in? That will turn it always positive. Absolute value. Squared would change the number, but if I put absolute value bars around it, then it doesn't matter which one comes first. So it will be this. You can only do this though if you have a calculator. It'd be from negative 1 to 1.2071, absolute value, f minus g. Okay? So go ahead and practice typing that in just to see that it comes out the same. Okay, but I do math 9 here. I'm going to go from negative 1 to 1.2071. And then when I get to here, remember it's alpha window to pull out, or no, yeah, alpha window to pull out the ABS. Crap. Okay. Here. Alpha window and then ABS. Right there. And then I'll do y1 minus y2. Now, just for fun, could you have done y2 minus y1? Sure. It doesn't matter because if you put absolute value bars, the order doesn't make a difference. Okay? And notice that even though it takes 100 years, okay, you still get the same answer. Boom. Okay? Shortcut. Now, if it's a free response and you don't have a calculator, you can't integrate absolute values by yourself. You have to have a calculator to do it. So you would have to break it up like we did on the previous ones. Okay? Alright, the last page. Okay, number 7. Do part A and part B. Part A, you're finding the area enclosed by the functions. Don't actually find them, just set up the integrals. And then part B, you're finding between the graphs on an interval. Okay, for part A, if I want to stay enclosed, I have to stay in this little region here in the middle. What are my boundaries? They're whole numbers. But make sure you give me y's because these are sideways, right? If it's a sideways parabola, you have to give me the y's of the intersections. So from where to where? This is how low? Negative 1 until 2. So negative 1 to 2, and then who's on the right side? The line or the curve? The line. Now, is the line in the correct format? That's a problem. We're going to have to fix it. So if y is x minus 2, then what does x equal? Y plus 2. Okay? So I'll do y plus 2 minus, because it's on the right, and then y squared on the left. Now, one other thing I just want to point out to you that's consistent, okay, is that if it's x plus 2, does it make sense? I'm sorry, if it's y plus 2, does it make sense, the graph? Right? Where does it hit the x-axis at? 2. So that's the same, okay? Then down here, where do I want to shade? Between the graphs from where to where? To 2. So when I start here, that's not low enough. Where do I need to start now? Down here. And that's going to shade me up through this pocket and then include the pocket above it. So that's what turns it into a swivel, is that you're starting lower. So we'll say that negative 2 is about here, and then I'm going to have to shade up through that intersection point.
That's helping you with computer stuff.
Okay, thank you. Okay. Then my integral would be from where to where? This is negative 2 to negative 1. And then who's on the right? Line or curve? For this pocket? That's the curve. So it'd be y squared minus y plus 2. And then for my second pocket, we'll call it number 2. It would be from negative 1 to 2. And then it's line minus curve, which is y plus 2 minus y squared. Now, or we're going to use our little fancy shortcut. If you had a calculator, what could you do instead? Negative 2 to 2, and then what would you put around your subtraction? Absolute value bars. Y squared minus y plus 2, and then call it a day. Okay, but remember, you would have to have the calculator to be able to do that one. Versus if you were doing it by hand, you would have to split it up. So it's either this answer or this long answer. Okay? And then also, I'll tell you that most of the time on the AP test, if it's multiple choice, they're going to show you the long one. Like if it's like you're having to pick which one's the right area or something, it'd be like this. They're not going to shorten it like that usually. Okay, number 8, I want you to just set it up. I want to see if you can graph the correct space. So sometimes they give you a graph, sometimes they don't. So graph that in your calculator and then set up what integral you think you should be typing in. And then we'll save number 9 for tomorrow. Okay, type it into the calculator unless you magically know what the square root of ln x looks like off the top of your head. Okay, because the problem is that one of my equations is a y equals, the other one's an x equals. So think about, for y equals, what did it look like in your calculator? It's just it almost just looks like a normal square root. Where does it start though? Does it start at the origin? Starts where? At 1. So here's 1. There's my graph. What does x equals e look like? Because I can't type it into the calculator. Is it a hoy or a vux? If it's x equals e. That's a vux. So you would have to know that when you can't type in it's x equals, well then that would be here. Remember that e is like 2 point something, right? So when I set up my integral, what is my top minus bottom going to be? The top is square root ln, but what's the bottom? The x-axis. What would I put for that if it's top minus bottom? What would I call the bottom if I want to integrate to the x-axis? That would be the same as 0, right? So my integral will be ln x minus 0. And then what will my endpoints be? What is my domain? from 1 to E. Does that make sense? So this is the top border, and this is the bottom border. Why is it 0? Because it's the x-axis. Okay? And then, I don't remember which one it is, but you can do it if you want. Okay, you have like 2 minutes. And then, if you will put your calculator up, that'd be stellar. I will be. Sure, yeah. Hey, Sean! Stop it! Sean! No. Because sometimes the aggression that you show in class is not acceptable. You're in a school, honey. Okay, I am not okay with you punching him 18 times in the arm. Have a great day. Thanks.